Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios, and what I have for you today is the examination of a question. The question is, does sprinting really slow software development down? Before we move into the actual content, I just want to say that this video was recorded on Monday, 10th of June. It's probably gonna be published on 22nd of June, so if anything happens in the meantime, you'll know why, because this is recorded ahead of time. This question was prompted by an article on the New Stack that attracted my attention, and the article is called "How Sprinting Slows You Down, a Better Way to Build Software." This article was published on June 6, 2024. It's written by A.G. Shankar. Let's quickly examine. A.G. Shankar is the founder and CEO of Everload, the cloud-native e-discovery platform that unlocks the collaborative power litigation and investigative teams. Okay, so he's running a product company, basically. And we'll go through his arguments, but the initial sentence here is: sprints promise to accelerate development, but often do the opposite. Check out this alternative approach to building software. And as usual, I'm very interested in alternative approaches at building software. I'm not, while I've done a lot of work with Agile, I think Agile and the core of Agile means fundamentally to figure out better ways. That's how the manifesto starts. We are uncovering better ways to develop software. So whatever other ways can be proven better, perfectly fine. There's also another video that I will probably refer here, which is a talk by somebody from Basecamp. I don't remember his name, unfortunately, right now. And he gave a talk at one of our conferences about how they are doing product development at Basecamp, and it's a very interesting thing because they basically have 6 weeks iterations, so not necessarily the 2 or 4 weeks, the 2 weeks of Scrum or anything else. And it's worth checking out that video if you're interested in, again, better ways or different ways of structuring your development. Now, I have to say one thing. Sprints promise to accelerate development. That's not actually the promise of sprints. I find it unfortunate that Scrum, and particularly Jeff Sutherland, pushed a narrative through his book on Scrum. And the book was called "Twice the Work in Half the Time." Whereas in reality, what we are trying to do with sprints is not to accelerate development, but rather to accelerate the delivery of value to users. And those two are different things. You can have very fast development, but develop the wrong things, the things that are not useful to end users or that are not useful to growing your business. But that's not the point of Agile, of Scrum, of anything, right? But it was a very good sale point to managers. So that's why I think very shrewdly he decided to go this way. And somehow this myth has persisted that sprints are about accelerating development. Actually, they are not. What we are trying to do is to be more mindful, and the most important part of sprints is the fact that we can deliver something and inspect the results and adapt. That's the main point of sprints, and that's why we use them. And we inspect and adapt on different levels. One level is delivery. How fast did we deliver? What practices have we used? Did we introduce bugs? Can we solve any of these. And the other one is inspection in terms of value. Did we deliver actual value for users? And then we also do inspect and adapt. So we inspect these things and then we adapt, which means that at every sprint, we should decide that for the next sprint, we'll do some things differently. And now, not only we do this at every sprint, we should do this every day, but okay, a sprint is a good enough. Well, many people will say it's not a good enough because it's too long to have improvement only at the end of the sprint. But look, for many teams, it's already hard to do that. If they can go to the point where they can do improvements every day, it's even better. But sometimes you need to look over longer periods of time, and yeah, it makes sense. So to me, these things make sense. But that's my first remark. Sprints do not promise, or at least that's not what we should take away from Scrum, from Agile, from anything. Sprints don't promise to accelerate development. On the contrary, what we try to do is to deliver the value faster. Because the alternative is we deliver stuff that is interesting for various people in the organization, but it's not actual business value. Let me give you one example. I worked in many teams while I was a junior programmer. Many teams in our organization were starting their development by building a framework. This was definitely very valuable for them, or at least perceived valuable, but it was of no value for the user. And often they didn't know how to build frameworks, and they ended up making a mess and slowing everything down to the point where features, when they eventually started to add features, the features are very buggy. It took a very long time to develop them and so on. So yeah, it depends on who is running the show. They can pick different things. Now, of course, one limitation of this model is that oftentimes it's hard to figure out what's valuable for users, because users don't necessarily know what's valuable for them. And for this, you need to apply discovery techniques. And I think we still have a friction between the discovery part of product development and the building part of software development. And maybe this is what we learn from this article. This is what part of the Basecamp method does. This is also part of what extreme programming addresses by going not in equal sprints, but in iteration based on the current goal. And the iterations are not necessarily equal. So we can see a lot of variation here, and particularly if you're working for a product and you don't exactly know what your users want, you're in a discovery process, it feels forced to go with 2-week sprint in which you develop something and so on. But remember, you can always reduce this. So sprints are maybe misunderstood also in the sense that people believe that a sprint should be 2 weeks, when depending on your needs, you can switch to 1-week sprints, to 3-day sprints, to 2-day sprints. You can do, or you can go the other way, although the other way is not as great. But I had teams, particularly working with software and hardware, that decided to, because they were waiting for new versions of the hardware to be implemented, and that part was hard to reduce to 2 weeks. So one of their options was to move to a 4-week sprint. So that's definitely, if you have good reasons, it's an option. And also, what Basecamp does is they do 6-week sprints, but with different goals. So you'll have to watch the video for more details. All right. Let's see. Software sprints have become an article of faith in the technology world. In competitive industries that are driven by software, companies feel immense pressure to ship new products and features before their competitors. Aggressive 2-week deadlines are common, with a small army of developers dividing up work, production line style, and racing towards an immutable launch date. I have a problem with the tone. So it's true that companies feel immense pressure to ship new products and features before the competitors. But aggressive 2-week deadlines, normally you negotiate in the team what fits within a sprint. And you should be using past data to do that. So if in the past 3 sprints you never delivered as much as you thought, then unless you've made some fundamental changes to your way of development, to your processes, then you probably need to take less in a sprint. So the goal of a sprint is not necessarily to be aggressive deadline. It should be a sustainable deadline. And that's a big part of Agile. Now, it's possible that this comes from the industry, from situations that I haven't seen. So we'll give him this, then maybe he knows what he's talking about, okay? But what if this isn't the best way to build products? I run a software company for the past 12 years, and before that I studied software engineering and received a computer science PhD in programming systems. While there are nuggets of wisdom in sprint scrums and the whole panoply of modern software methodologies, they're not how we develop software today. Okay, let's see how you do it. Sprints promise to accelerate development, but often do the opposite. Moreover, the relentless pace and unsatisfying nature of sprints have developers burned out and quitting. Despite the uncertain economy, less than half of developers say they're very satisfied with their current jobs. Okay, I've heard about this. It's something worth looking at, but I think part of it is misunderstanding these things. But in the end, it is what it is. So if that's the situation, it's definitely worth looking into how to improve. However, let me be clear on one point. I think no matter what other new thing will come that companies will adopt as a way of working and so on, it will have almost certainly the same fate. I mean, first, could be interesting for developers. Let's assume it's something that's really great for developers. I fear that eventually, when it goes into the corporate environment, it will become diluted, misunderstood, adapted to the point where it doesn't resemble the initial intent. So I'm afraid that's the fate of anything. And it's not the... many people would say that Agile does not work or Scrum doesn't work, and I don't think that's the problem. I think the problem is this ecosystem that will kind of always go like this. It's as long as we have misaligned incentives and managers don't fully, who have to serve two different goals, one inside the corporate environment and the other in terms of, showing that they are doing the new shiny thing. There will always be a dilution of this thing, no matter how good it is. So yeah. Therefore, all these kind of different ways of working I think they could work really well in specific contexts, and if your context fits the context of this organization, then it's definitely a reason for you to look into it. I wouldn't get fixated on using Scrum or whatever, but be very careful what you try to adopt, because eventually it gets diluted. The approach we use empowers engineers to build the right functionality in the right way without imposing deadlines. It favors leaner teams that are given autonomy to design entire features, not just a component that they build in isolation. By the way, that's another problem. So normally a team in Scrum should be responsible for a piece of the value delivered by your system. What I mean by that, it could be a functionality area, or it could be a business goal. For example, there was a company, Prezi.com, that was building an online presentation tool, like for slides, but the slides were kind of like a mind map and a different style of navigation and so on. At one point, they had a team that was fully focused on bringing site visitors to visit the site for the third time, because they noticed that when a visitor would come back a third time, they were more likely to buy the product. So that was value for the business, and they had a team focused on that. And that was a goal. This is very different from a team that has a microservice somewhere in the middle of a system, and it's not very clear who it's gonna talk to and so on. Right? And that, unfortunately, is the situation. This second one is the situation for many development teams nowadays. So it's kind of as I said, the dilution of Scrum. It should be value from top to bottom, and you are responsible for delivering that value, and you have freedom within constraints, of course, but you have freedom on how to deliver that value. Okay, but let's go through this. It favors leaner teams that are given autonomy to design entire features, not just a component that they build in isolation. Perfectly fine. Completely agree with that. And critically, it involves exercising discipline with customers to not promise delivery dates for new software. Again, this would be great. The end result, perhaps surprisingly, is a development process that yields higher throughput. More features shipped per unit time. Yeah, and by all definitions, this would be an agile process because, well, as long as you do inspect and adapt, focus on customer value, absolutely. It's an agile process, but it's not based on sprints, it's based more on flow. Absolutely fine. I encourage you to consider this approach to development rather than defaulting to industry norms that lead to high levels of technical debt and developer turnover. Okay, so it's not the industry norms that lead to that. I mean, okay, it's the industry norms, fine. It's how they are applied. But I've seen different people applying them differently, and there are actually large organizations that care a lot about technical debt and figure out ways to deal with that. So it's not completely, based on my experience, I wouldn't call that an industry norm, even in practice, rather than the model. Sprinting slows you down. Deadlines have a different impact on software development than they do on other disciplines. Sprints can have significant negative long-term consequences, encouraging developers to commit substandard, myopic code to stay on schedule. This leads to lower code quality, poor engineering decisions that are costly to fix later, and frustrated engineers. They can, but it's not necessarily so. So how would an actual correct agile process based on sprints look like? What you want to have at the end of the sprint is, yes, features, a small piece, a small solution implemented to a part of a problem. So let's start actually from the beginning. You have a feature that you need to implement. You split the feature into smaller pieces. You figure out kind of how much you can do in a sprint, taking into account all the work required. That includes good engineering practices. So it's not about substandard code. It's not about low code quality, poor engineering decisions. Okay? However, one relevant concern is if you do things like this, it's possible that some of the decisions that you made here will need to change later on. But that is the nature of developing software, because developing software is a learning process and we learn by doing, and that's what incremental software development is about. And you fix those things as soon as you can. You don't let them for a very long time. And I discuss more about this in a video on incremental design versus rework. So I don't agree that deadlines will lead to this. They shouldn't. This is just developers being unable to work in an incremental manner. And if you have that, then there are two options: either increase the sprint or teach developers how to work in an incremental manner. So while at any given moment it may seem that throwing developers into sprints is the fastest way to get things done, in reality sprinting leads to less new software being developed over time as the negative effect of sprints compound. Again, maybe in many organizations, but this is not the desired goal. And by the way, if after 2 sprints you notice negative effects, you should do inspect and adapt, figure out the root cause, change your development practices in order to account for that so that it doesn't happen again. It's incremental learning. It sounds intuitive that if you are sprinting, you must be moving as fast as possible, but in the world of software development, you rarely end up sprinting in a straight line. Often you are zigzagging from one high priority issue to the next, addressing issues and defects that were introduced in the past due to the pressure of deadlines. Yeah, but that's okay, that's a quality problem. Okay, if you have that kind of quality problem, you really need to change the way you work. I have worked with teams that were developing at the same speed 3 years after the first sprint, and sometimes even slightly faster. But there's a whole way of doing that which involves engineering practices on one hand, the extreme programming ones, and also continuous inspect and adapt practice and mindset. Whenever you see something escaping this process, you go back to the source, figure out what went wrong and how to fix it. And the problem is that these are not translatable from one team to another, so each team needs to go its own way. This is a different thing. If you jogged in a straight line instead, you'll very likely have covered more ground and be less exhausted to boot. Okay, so this goes back to one assumption that I often see, that development is a straight line, and it's not. It's non-linear by nature. I think it's missing I think this section is missing the point. Software deadlines favor speed over quality. Many leaders think about software in the same way they do about other parts of the business, with an operational cadence driven by deadlines. Just as a marketing team is required to produce its holiday ad campaign by October 31, or a finance team to close its book at the end of the month, so engineering teams are ordered to release a new product or feature by a set date. This thinking overlooks the fact that software is fundamentally different from other business practices in a way that makes it ill-suited to deadlines. Yeah, I actually agree with this, in the sense that a feature by a set date, you should never have a feature linked to a set date. You should never have a product that contains a specific set of features linked to a set date. But other than that, you can have a delivery at a set date with whatever is done to the level of quality that you define as part of your definition of done, as part of your engineering practices, and so on. Okay, here are 3 significant reasons why developing software is fundamentally different from other business practices. Work is typically done in the context of a large complex code base. Correctness in software is a much higher standard than in other business areas. The downstream effects of good or bad decisions are massively compounding. I actually agree with all these 3. That's true. Let's break this down. Code bases are complex beasts. First, it's hard to anticipate the time it will take to implement new functionality, even simple functionality, because it's rarely done in isolation. Instead, new features are typically added to an existing code base, and its subtleties and nuances, such as issues around security, performance, and maintainability, are often discovered only when writing the code. And because code is so interdependent, adding new functionality to good implementations often requires rewriting other code on which the new functionality will depend. This creates tension with a preset deadline. As an engineer dives into the code and a deadline looms, they often might take shortcuts, spaghetti code, brittle implementations, and so on, even if they know the right way to implement something, simply because the deadline did not anticipate and cannot accommodate those challenges. Yeah, but you just don't ship it. So if this happens, this is not a shippable feature. It does not go into the product. So, okay, so I agree in principle, although it's missing some things. I agree that you discover the implementation while writing the code. That's absolutely correct. There are a lot of nuances, a lot of issues, a lot of things that you need to, subtleties, as he's saying, absolutely so. Completely agree with that. Where we disagree is kind of like why one sprint should definitely fit this, because you need to be, so the goal of sprints is not to deliver blindly and say, oh, we have a sprint by this date, so let's lower the quality, run some spaghetti code, and just make it work. No. The only way agile processes work is if they have quality built in. How do we build quality in? That's where I don't like Scrum, in the sense that Scrum has drop the engineering practices, and you should take the engineering practices from extreme programming. Test-driven development, merciless refactoring, pair programming. These are things that these are practices that if you use them continuously, they keep your cost of change constant, right? And if you cannot, let's say the sprint ends, you have used these practices, but the feature is not finished to the point where it was defined in the beginning of the sprint. That's fine. We just didn't finish that. And it moves. We continue and solve it in the next sprint. We never should negotiate on the quality, on the practices, on, just drop the tests and, make it work. All right, maybe there are situations, but they should be very carefully taken into account, and usually they lead to other problems later on. So the way you do that is, let's say you do not finish it, therefore it's not done within the sprint, therefore it does not go into the product. And you have the next sprint to figure it out. And the second thing you do, inspect and adapt. You inspect what happened with that feature, and you adapt your processes such that this thing does not happen again. Maybe the feature was too large in scope. Maybe there's a part of the code that needs special attention to be cleaned up, refactored, and so on. And that's a ticket that you take in the next sprint. Whatever. Maybe there's other things. Maybe you need other practices. And that's how you go. So this is perfectly compatible with sprints. It will not make managers happy if you don't deliver what you promised in the beginning of the sprint. But that's life, and this is what we have to keep reminding them that, look, software development is non-linear. These things happen, they will happen, and that's it. The only thing that we can promise with sprints is that by the end of a sprint we'll have something done, not necessarily everything that we set out to do. Hopefully everything. Hopefully something extra, if everything goes nice, goes well. And yeah, but sometimes we'll deliver less, and then we'll adapt, inspect and adapt to figure out what to do differently. That's all there is. There shouldn't be anything more. So these are excuses that a preset deadline goes to this. A sprint is not a preset deadline. A sprint is, the end of the sprint is the date when you demo what is done, which might not include everything that you promised, and when you inspect and adapt on the sprint. That's all there is. It's just a time box. It's not a preset deadline, and you really need to hit that deadline with a specific feature, or else, something will happen. And if management pushes for that, unfortunately, that's a kind of toxic behavior. It's not correct. All right. And yet another way of dealing with this is, of course, removing the deadlines, and then you go into a flow. You are using a flow-based system where basically you have a list of things ordered by importance. You take the first one, you implement it. You take the second one, you implement it. And it's done when it's done. That's absolutely fine as well. The only problem is programmers tend to take larger things because honestly, we would prefer to be left alone and just work on our thing for as long as possible. But it's not the best way of doing things, and because of that it's better to split into smaller pieces. So incremental development, that's the key here. Either way, whatever you're doing. A higher standard for correctness. Second, what it means to be correct in software is unlike what it means for a marketing plan or sales strategy. You can write a good enough press release by a fixed deadline, and if it's serviceable and factual, even if imperfect, it can be shipped. However, in code, any deviation from ideal is considered a defect and must be triaged. Can either be ignored, resulting in customer ire, or fixed at great cost in production, typically several multiples greater than fixing before the release. Deadlines push more bugs into production, leading to more engineering time spent on fixing these costly production bugs and less time on building new functionality for customers. So I agree with everything until the point where it's saying deadline push more bugs into production. Once again, it's misunderstanding the notion of sprints. You take a user story or whatever it is, a feature, in the beginning of the sprint. It's done when it has no more known bugs. No more known bugs. Which means you've implemented it, you've tested it, ideally first with automated tests, then a person has tested it. You've reviewed it from different perspectives for security, for performance, for scalability, and so on. And only then you can say it's done. And if it's not done, it does not get shipped. It's as easy as that. So yeah, and that's precisely why. This is the reason why. Because, I mean, he's right. When you get more bugs in production, it's much more costly to fix those. Okay, bad decisions compound. Third, the downstream impacts of poor implementations and architectural decisions continuously compound. The marketing pro can write a bad press release today, but then a good one tomorrow. But new code is dependent on old code, how it functions, how it's structured, and what paradigm it uses. Even code without obvious defects can be deficient in these ways. Hasty decisions about how to architect an application now can make it much harder to add new functionality later on, slowing down development over time. This technical debt is the scourge of engineering departments. Sprints may allow you to release a particular feature more quickly today, but at the expense of compromising future development. That's not completely correct. Because hasty decisions about how to architect an application now can make it much harder to add new functionality later on. All right. There is a special kind of architecture that you need to apply with Agile. And I think it's not necessarily to apply with Agile, but in Agile is more prominent to have the need for such architecture, but it's needed for any kind of product where you expect change. And it doesn't matter what type of methodology you use, because the architectural problems will stay the same. And that style of architecture needs to be open to change. Okay? You cannot make all the decisions immediately. And no matter what you do, and that's another thing about architecture, no matter what you do in architecture, you will make decisions based on incomplete knowledge, and some of your decisions, therefore, will be wrong, and you will need to change them. And this is not a function of Agile or not Agile. It's just a function of how the world works. You do not have the luxury of waiting for complete information. You only have complete information about the system when you have implemented everything and it actually works in production. That's when you have the complete information you need to make a perfect architecture in the beginning. Only you do not have that in the beginning. So definitely you'll make decisions that are wrong. And there are a few ways to deal with that. One of them is to leave yourself enough space to kind of wiggle around. Another one is to delay or to validate, actually, to validate certain decisions with prototypes. Another way is to delay certain decisions by implementing other things first and then going into that part, and so on. So technical debt, no matter what methodology you use, it will be part of your process. And you need to take it into account. Now, even with test-driven development, with merciless refactoring, with all that, you might still end up with some decisions that you made at some point that are not ideal at the current point. Only what you do then, you embrace change. You go back, change the system, and you do what is called architectural refactoring. Restructure modules, reorganize behaviors, all kinds of things. All right. So it's not necessarily a problem of sprints. I agree that many teams face problems with architecture in Agile, but that's mostly because architects need to learn how to deal with these problems in a more structured way. Most people who are architects in organizations are people who have been developers and then become architects, and architect is a completely different job. This is why we have a learning program called From Developer to Architect that teaches developers what to do as architects. And we also have some more advanced programs on software architecture where we dive into deeper things. More people, more problems. When you are trying to ship a critical new feature by a certain deadline, it's common to assign lots of engineers to it. However, large engineering teams suffer from two challenges: significant communication overhead and siloed implementation. These challenges reduce efficiency and quality of work. What are we talking about here? I don't understand. So, okay. This is separate from sprints, but what it's talking about is large engineering teams. And when we talk about agile software development, you would have small engineering teams. The ideal team is probably 5 people, from my experience. That includes programming, testing, some operational abilities, and analysis, of course. And please notice that I'm talking about skills and not necessarily about people. So it's not one analyst, 2 developers, 1 tester, so on, but it's about skills. Maybe the tester also knows how to write code, and maybe the developers know a little bit about testing or a little more about testing. But you need the specific skills in the team. Doesn't mean that the skills are structured in a specific way. So large engineering teams suffer from these challenges? Absolutely, yes. Yeah. And then you have to have, well, if you have bigger features, there are 2 options. You either have a few teams that go very quickly, can do this, but also write, not only fast, but also write. Or you have, you parallelize it, split into multiple teams, and then, yeah, there needs to be some coordination between them. Although siloed implementations, yeah, maybe it's a function of Conway's law. When each developer has a narrow slice of a larger implementation, they're forced to spend time coordinating with each other, and even then, structural issues make it difficult to deliver high-quality implementations. Consider a front-end engineer whose job would be much easier if the back-end team would change the API to expose a critical piece of information to the front end. The amount of communication reprioritization needed to effect changes like this is often so great that most engineers simply don't bother. I mean, why? Okay, so here's how you do that. You go to the backlog of the other team and add the request for this. And by the way, okay, so let's assume if you are part of the same product, you should have only one product owner. And the fact that you need to implement something in your feature in your front end means that you have a request from the product owner, which means the backend will also have the same request for the product owner to make the change. And then, first of all, you build your change assuming that the other thing happened. How do you do that? You go meet with the developer from the backend team. You decide on a contract, like an endpoint, parameters that you are sending, what values are returned. You write together the kind of stub for this backend. You write tests for it, and this becomes your contract. And then you implement your code assuming that the other thing is done. When they get to it, they implement the thing based on the test that you have. And that's it. Yeah, there is some coordination, but it's not such a big deal. Of course, it would be much better if you would have front-end and back-end in the same team. That's ideal. But this is not a function of sprints. This is a function of organization of teams. And I would prefer to have a team that has front-end and back-end abilities, front-end and back-end skills anytime. Unfortunately, with the advent of React and all these complex front-end technologies that are, in my opinion, not really needed, look at HTMX, you have all kinds of issues with that, in the sense that one person can no longer learn both front-end and back-end because it's too complicated. It's too much. And you cannot stay up to date with everything. But if you do something like HTMX with web components, I think you solve this problem fairly quickly because it's not such a big deal. Okay. So, yeah. Even more, the best implementations aren't just locally optimal for every slice, they're globally optimal for the whole feature with a coherent implementation across the stack. These implementations are virtually impossible to achieve in big team systems, since no one, save for an omniscient architect who can foresee every issue, has the authority to make all the necessary changes without superhuman levels of communication. Yeah, but the thing is, what you do is you adjust, right? It's always inspect and adapt. You implement something, you see it working, then you inspect, adapt, have new things to do. Of course, ideally, you'd make it right from the first time, but even if you have smaller teams, this will not happen. Maybe it will happen better or more often, but not 100%. Now let's see what's the solution that he proposes. Kill the deadlines, shrink the teams. Okay, that sounds good. I agree. You can definitely do that. How might we build a system that delivers high quality code with high throughput and happy engineers? First, start by killing the deadlines. In our model, engineers determine when a feature is ready to ship. All right, this is what you should do in Scrum as well. It's exactly the same thing. They are thus able to make principled engineering decisions about what to implement now versus later, delivering better code than they would when making decisions driven by a 2-week deadline. Yeah, I'm starting to be bothered by the 2-week deadline. It's not a deadline, it's a time box. It's slightly different. If people understand it as a deadline, it's wrong. Okay. So basically everything would work with sprints understood as time boxes as well as in this model. Just a small comment. I said before that engineers decide when a feature is ready to ship. That's absolutely right. You have a definition of done, and the definition of done is owned by the team. So they decide it, right? Now, if you don't follow the definition of done, okay, whose responsibility is that? It's engineers. You have to stand up for that. Second, assign smaller teams to features and give them greater scope. Because the teams are smaller, often just one engineers, oh boy. Many new features are developed in parallel. The solo programmers or small teams own the entire implementation from back to front. Okay. There are no daily stand-ups and needless communication is eliminated. Okay. And because the engineers control the implementation across the stack, they can make principal engineering decisions about how to build their functionality rather than decisions constrained by the sliver of the code base they happen to own, delivering a more cohesive implementation. Okay. Nothing wrong with that. So nothing, even in Scrum, nothing says that you should have 7 people. You could have 2 people. You just need to cover a few. So the only thing that a team needs to have is the ability to deliver on its goal only with the people in the team. So one thing that I'm missing here is who does testing. Because I am definitely okay with teams that have 1 person or 2 people. I don't care. As long as they do everything. So they should do the analysis, they should do the implementation, they should do the testing, deployment, monitoring, fixing bugs, everything. And if it works like this, then it's basically extreme programming. So, yeah. The common thread between these 2 ideas is that they institutionally support making principled decisions because good decisions today lead to better outcomes tomorrow. This fundamental truth is easily overlooked when engineering is treated like any other department that does not have the context, correctness requirements, or compounding downstream impacts of writing code. The counterintuitive result is that even though individual projects take longer to ship, no deadlines, smaller teams, total productivity is higher. We have many more projects in flight and being completed, and each engineer is able to get more done because they're spending less time dealing with critical production bugs and technical debt and more time writing code in a high-quality code base. Yeah, but that's basically extreme programming in a nutshell. I so like when people rediscover extreme programming. It's so funny to me. Engineers are happier too. They don't have to put out fires that they lead themselves to a little deadline. They collaborate more freely because they don't have to weigh helping a colleague out against the deadline hanging over their head. Okay, I'll stop commenting on the deadline thing. And because they're not siloed into a particular sliver of the code base, they're constantly learning new concepts and tackling novel challenges. The downstream benefits are a stronger culture and better engineers. Keeping your customer happy. You might ask, how do we get products out the door in a timely manner with no deadlines? First, it turns out that engineers like shipping code, and because they own entire features, they are highly motivated to see their projects come to fruition. Okay, that's a function of the engineer. I've seen people, engineers, software engineers, who are very happy just writing code and not having to think about customers at all. Okay, so this is a function of what type of people you hired. And to me, that's a precondition. This kind of person is a precondition for extreme programming to work. If people are interested in solving problems for users, perfect. You can go with extreme programming once you give them the right skills, which is the second part of the equation. And I feel that the reason why many corporate organizations favor the other types of organization is also because they know many of their engineers prefer to just write code and not to think about users. I'm sorry, but that's that's the reality that I've seen. Second, our engineers do not make decisions in a vacuum. They understand that delivering software is our primary market advantage in a competitive industry, that our users rely on new functionality from Everload to remain competitive themselves, and that we reward strong performers like any other business does. Ooh. Are you doing individual evaluations? Question mark. Okay, this might get you in trouble later on. We'll see. Third, there is a lot of support and transparency. Leaders check with teams weekly on the progress of their software to address any roadblocks. Really? So they're doing basically a 1 week sprint where they do the inspect and adapt thing, but only in something that they do not call an inspect and adapt meeting. Okay. So basically extreme programming. We are not running a free-for-all where everyone gets to follow their own path. We just don't set arbitrary deadlines that compromise the quality and the enjoyment of the work. Yeah, extreme programming. Another common question is how we make commitment to deliver specific features to customers by a specific date. And the answer is that we do not. Very good idea. Our customers are happy because we produce high-quality software and deliver new features more frequently than our competitors. Remember, the entire point of our approach is that we release more software over time. Yep, extreme programming. We do, however, share our product roadmap with customers so that they may influence its direction and priorities. Extreme programming, again, the customer is part of the team. But if a prospect says we need this feature delivered by October or you won't win our business, we'll decline because doing so will compromise the quality of our product and do a disservice to other customers. A surprising amount of the time, these prospects understand the value we offer and sign on with Everlow anyway. And of the ones that don't, we know they'll be back because we'll be even further ahead in a year or two. This model requires discipline at the leadership level. And an understanding from the go-to-market side of the house that as the result of this policy, while we might lose 3 deals this year with this policy, we are going to win 30 more next year on the back of a cutting-edge product. Yeah, absolutely. The long-term approach wins the race. Our model focuses on long-term outcomes rather than short-term ones, and thus is not the right fit for every business. For instance, very early-stage startups that are still identifying product market fit need to experiment quickly to figure out what the market wants. They may want to test hypotheses rapidly and so favor speed of development on a small number of features over throughput across many features. Actually, you can use extreme programming with early stage startups, but you focus on running a large number of experiments rather than building a large number of features. And you probably have, as I was discussing in the beginning, you probably have this, you have 2 operation modes. One is implementing something for an experiment, and the other one is implementing a feature that has been proven. Some For some teams, it's possible for engineers to switch between these modes. For other teams, you need separate teams to deal with experiment versus development, which is where friction comes. It's that we don't really know how to do this in a better way, as far as I can say. As soon as they establish product market fit, however, the engineering goals change from predominantly experimentation to predominantly execution. Well, it shouldn't really, because you keep doing experiments, but maybe, yeah, I agree. Not as much experimentation, but more execution. But still a lot of experimentation. They'll know what they need to build to win in their industry, and now they simply have to get there as fast as possible. Our model is best for them. Extreme programming. The golden trifecta of software development is to have a team of happy, motivated engineers who write high-quality code and ship lots of functionality. Engineers love working in our system because they have ownership over what they do. They do not have to compromise technically sound implementations to hit arbitrary deadlines. They are always learning new skills and domains rather than being siloed in a narrow part of the code base. They are not constantly putting out fires in production code, and they ship meaningful, cohesive solutions with a high frequency. The emphasis of high-quality code drives development throughput, which ultimately benefits the whole business and the users we serve. All right, so this is a very interesting article, but my feeling, as you could see from my reaction to it, is they have basically rediscovered extreme programming. And I see more and more articles of this kind with organizations who try to deal with some issues in Scrum and end up rediscovering extreme programming. So maybe consider extreme programming in your projects, or better said, for your products, because it's really a great approach. And I believe it is, but it takes some time. I think it's a function of two things. One is engineers who want to solve problems for users rather than write code, and who are very engaged in this process. And the second thing is engineers who have the right skills to do front end, back end, everything. And that's a function of the technologies you are using, but also it's a matter of learning the different things and being open to learn the different things, because some engineers would want to be, I don't know, a React engineer or a backend Java engineer or something like that. And if they do that, then it's slightly difficult to open their paths. So yeah. All right. So based on this, I would say that the problem is not necessarily sprints. It's a misunderstanding of sprints, and it's basically a rehash of extreme programming or of a flow-based development model, which is also a very valid model. The most commonly known way to organize that is Kanban, but it's not the only way. Okay, so what do you think about this? Have you seen these situations in your career, in your work? Do you have any other questions about organizing your teams or for product development? Let us know in the comments. As you know, we love comments. One of the perks of this channel is that if you write a comment, the answer might be a video, so who knows? So yeah, leave us comments. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.